Hi everyone, let's start numerical analysis. This topic has been my favorite since my college days. Yes, this was one of my electives in third year of my college. Coming back to the videos that I'll be making, I would be referring to my college notes and then Greva Numerical Methods textbook for some problems and examples, followed by a PYQ videos for that particular topic. Let's come back to the topic. So we know that any equation which is in the form of a0 x power n plus a1 x power n minus 1 plus so on an is equal to 0. So here we see a0, a1, an are all real numbers. So what is this equation called? This equation is algebraic equation. This equation is algebraic equation. So what are the examples of algebraic equations? We can say x cube plus 10x plus 9 is equal to 0. Or we can say x power 10 minus 9x power 9 plus 7x plus 1 is equal to 0. So in this algebraic equation, we see that the degree is 3. Similarly, in this algebraic equation, the degree is 10. So, this algebraic equation is of degree 3 and this is of degree 10, right? Also, we know how to find the roots of these algebraic equations, correct? If it is a quadratic equation, we find in a different way, and if it is a cubic equation, we are already aware of how do we find the roots. So we also find the roots in graphical way as well, right? If it is a cubic equation, if you see wherever the graph intersects the x-axis is nothing but your roots. So we have different ways. So this is a way we find out the roots for algebraic equations. Now what about equations which are, let's say, like this: e power x plus x square minus 10 equal to 0. What do we call these equations as? These equations are called as transcendental equations. These equations are called as transcendental equations. So transcendental equations, what do we mean by it is the equation which will have exponents or logarithms or trigonometric. So all these kind of equations are called as transcendental equations, or wherever. So these are transcendental functions. If they are present in the equation, we call them as transcendental equations. So how to find the roots of these transcendental equations is something which we are going to see. Okay, so the methods which we will be seeing, right, the bisection methods, all of those. So those help us to find the roots of these transcendental equations. Okay, now we also know that, for example, we have x square minus 1 is equal to 0. We know what is the root of it, right? We know that the root is nothing but x is equal to 1. 1 is the root. So how do you verify that 1 is the root? We just verify by substituting the value of x, right? So x is 1, I am substituting 1 square minus 1 is equal to 0. So this is satisfying this equation. So we know that this is the root of the equation. Okay. Also we are aware that algebraic equations, if they are of degree n, they have n roots, correct? So if it is a cubic equation, we have some cubic equation, the root is, the number of roots are 3. If it is of n degree, the number of roots are n. But what about transcendental equations? We cannot tell how many roots are there for transcendental equations. We are going to find out the roots of transcendental equations. We can also find algebraic equations roots also in these methods. Okay. So yeah, let's start with our actual method, which is bisection method. So this bisection method is one of the methods which helps us to find the roots of transcendental equations. So bisection method. So there is an interesting analogy which I read. So how do you find the root of any equation in bisection method is, let's say there is a huge room, and in the room there is a key somewhere. Okay, let's say there is a key here. Okay, you lost your key in the room, or let's say you lost your mobile phone. Okay, mobile phone would be a good example. So now you want to find out where your mobile phone is. Okay, and the room is, let's say, very very big. So what do? Is you try to ring your phone. Since the room is very big, you'll try to divide the room into two halves, and you'll see if the phone is here or here. Okay, you try to hear the sound and see if the sound is coming from this part or this part. So you might get an idea that okay, somewhat sound is coming from this part, so room might be from this part. So again we divide into half and see, is it from this part or this part, and so on. So similarly is a way for finding out the roots. Okay, we take an interval and we divide the interval, and we check if the root can be from this one or this part. Okay, if we, and then again we try to shrink the interval further. If we feel that it's from this part of the interval, we again shrink the interval and we try to check where the root is. Okay, so let's say our equation is f of x. Okay, now if they have given the interval, sometimes in the questions they give the interval that your root might be in interval 1 comma 2 or whatever. If they have given the interval, it is well and good. Otherwise, always remember f of a times f of b should be less than 0. Okay, so let's see what this is. Okay, now if our equation is, let's say, x cube minus 2x, let's take x cube minus 2x minus 5 equal to 0. Okay, so now let's draw a table. So this is f of x. Here I'll be writing f of x, and here I'll be writing x. What if x value is 0? What do we get? 0 minus 0 minus 5. It is minus 5. What if x value is 1? You get 1 minus 2 minus 5. What is it? 1 minus 7, which is minus 6. Let's say x value is 2. It's nothing but 2 cube 8 minus 4 minus 5. So f of x is minus 1. Let's say now x value is 3. 3 cube 27 minus 6 minus 5, which is 16. Okay, so now we see that if you see f of 2 times f of 3, okay, f of 2 times f of 3 is how much? F of 2 is minus 1 times f of 3 is 16, which is equal to minus 16, which is less than 0. Okay, so when you know that f of a into f of b is less than 0, that means the root lies between them. So the root of the equation will lie between 2 and 3. Okay, that is the first thing which we have to consider. So we have to find out the points a and b such that f of a into f of b will be 0. Okay, so sorry, f of a into f of b will be less than 0. So if you get the root, okay, f of root directly gives you 0, correct? If you know the value of the equation, if you know the value of x, if you know the root value should directly result in 0, okay? But if it is giving as less than 0, that means the root lies between this interval, okay? So now let's start with an example and understand how we can solve the question. So our question is x cube minus 2x minus 5 is equal to 0. So now let's draw a table, and here let's put the value as I. Here let's put the value as xi. Xi is a plus b by 2. Remember, we shrink the function, right? We try to divide the room to find out the mobile phone. Similarly, we will be dividing the entire interval and trying to find out where the root will be. Okay, then let's see what is f of xi. So after we divide, we'll find out what is the value of f of x. Okay, and yes, then we will also see what can be our interval a comma b. Or let me do one thing, I'll write the interval here itself. So it's xi equal to this. I'll write a comma b. Interval is here. Okay. Now initially, in the first step, what is the interval we have got? 2 and 3. So if you notice here, f of 1 into f of 3 is also less than 0. You can consider this as an interval also. But when we keep shrinking, we again end up getting a value between these two. Okay. So if you find any two values, it is good to take. So we have got 2 and 3. So 2, 3 is A and B. Now what is xi? 2 plus 3 by 2, which is 2.5. Okay. So now let's find out what is f of 2.5. If it is giving 0, we know that it is the root. But let's see, what is f of 2.5? It is 5.625. Okay, we can use our calculator to calculate. It is 5.625, which is greater than 0. Okay, so what is f of 2.5 giving us? It is giving us greater than 0. So what do we want? Now we have 2 and the middle number is 2.5 and we have 3. So the value of 2, f of 2, what does it do? It gives less than 0, right? Minus 1 is less than 0. F of 2 is less than 0. F of 3 is greater than 0. Now again 2.5 is also greater than 0. Okay. So now we'll shrink the interval further and we will be taking these two. Okay. Our next interval will be these two, 2 and 2.5. So second case, it's 2, 2.5. Now what is xi? It's 2 plus 2.5 by 2. So you will get it as 2.25. Now what is f of 2.25? It's 1.891, which is again greater than 0. Okay. So now we have 2, which is giving us less than 0. We had 2.5, which is again giving us greater than 0. And we have middle value as 2.25. It is also giving greater than 0. So instead of finding something between this, we will find out, we'll consider this interval because our root might be between these intervals, right? One should be less than 0, other should be greater than 0. So our third step would be between 2 and 2.25. Okay. So what is xi? 2 plus 2.25 divided by 2 will be 2.125. Now what is f of 2.125? It gives us 0.346, which is still greater than 0. Okay, so we have taken 2, 1 second, we had 2, 2.25, and now the value is 2.125. Okay, so 2 was giving us less than 0, 2.25 was giving us greater than 0, and 2.125 was also giving us greater than 0. So instead of taking this, now again we'll shrink the interval to this. So our next value, fourth value is 2, 2.125. Okay, now what will be xi? 2 plus 2.125 divided by 2, which will be 2.063. Let's see what is f of 2.063. It is nothing but minus 0.346, which is less than 0. Okay, now we have got a value which is less than 0. Okay, now what we were doing, we have 2 which was giving us less than 0. Then we had 2.125 which was giving us greater than 0. Now we have in the middle 2.063. What it is doing, it is also giving less than 0. So what we will take, we will shrink the interval and take one should be less than 0, other one should be greater than 0. So we will not take this part because this part will not be helpful for us anymore. Okay, so now we are shrinking the interval this side. So now the values are 2.063, 2.125. So in this question I am rounding to 3 decimals. So actually in the question it was given to round to 3 decimals. So what will be our xi? 2.063 plus 2.125 by 2 will be 2.094. Okay. Now what is f of 2.094? It's minus 0.06, 0.006, which is again less than 0. So what we had 2.063 which was giving us less than 0, then 2.125 which was giving us greater than 0. Now we got the middle one as 2.094. What it was doing, it is also giving less than 0. So now we will shrink the interval further and consider these two. Okay, so a hint to remember is the middle value should be considered always. Along with it, what you have to consider, greater than or less than, is something which you have to understand. If it is less than, if this is giving us less than, we will take something which is giving us greater than 0. If it was giving us greater than, then we would have taken the less than one. This is like a trick which I just remember. So now we have 2.094 and 2.125. Now what would be our interval xi? When we divide both of this, we get 2.110. Okay, now f of 2.110 is 0.174, which is greater than 0. Okay, now have you noticed? Now we got something greater than 0. So we had what we had 2.094 which was less than 0. Then we had 2.125 which was giving us greater than 0, and now we got 2.110 which is again greater than 0. Okay, so this value we will include. This is greater than 0. And which one is less than 0? This one, correct. Now our interval would be only this. So seventh one, so it's 2.24. It's not 2. It's 0.94. So 2.094, 2.110. Now what would be our xi? It's nothing but 2.102. I'm just dividing by 2. I'm adding these two and dividing by 2. So 2.094 plus 2.110 by 2 is 2.102. I'll just erase this. Unfortunately, erasing is taking more time. Okay. So what is f of 2.102 now? It is 0.083. Now greater than 0. So now tell me what would be our interval? 2. So we had this one less than 0, this one greater than 0, right? And we have got something greater than 0. So if you got something greater than 0, you'll include the lesser one, correct? So the next interval is 2.094 comma 2.102. Okay, now xi value is 2.094 plus 2.102 divided by 2 is 2.098. Okay, now f of 2.098 is 0.039, which is greater than 0 again. So by now it would be clear that since this is greater than 0, now we will take something less than 0. So this was less than 0, this was greater than 0. So we will obviously take this 2.094 comma 2.098 is our interval. Are we noticing the interval was 2 comma 3? Now for finding out the root, we have almost stringed it to 2.094 and 2.098. Now our xi is 2.094 plus 2.098 divided by 2 is 2.096. And f of 2.096 is 0.016, which is greater than 0. Okay, so now this is greater than 0. So this one was giving us less than 0, this one was giving us greater than 0. So what would be our next interval? Right, 2.094 comma 2.096, right? So one is, since this is greater than 0, we will include that one plus less than 0 one. If this was less than 0, we would include this one and something greater than something which gives greater than 0. So now what is xi? Xi is 2.095. Now f of 2.095 is giving us 0.005, which is greater than 0. For 3 decimals, no, if it would have given 0.005, we would have considered this itself as a root. Unfortunately, it is 0.005 still. Okay, which is greater than 0. Again, this was less than 0, this was greater than 0, right? Now we want something less than 0 again. Okay, so 2.094 and 2.095. Okay, since we have got this f value as greater than 0, from the previous interval we will take something less than 0. Now what is xi? 2.094 plus 2.095 divided by 2. So what is the value of it? The value of it is again, I think, approximately 2.095. So when we are getting the same xi's approximately, we can, correcting to 3 decimals, because in this question it was 3 decimals, so we can tell that this itself is our answer. So the root of x cube minus 2x minus 5 is 2.095. Okay, so this is how we solve. Hello everyone. In the previous video, we have seen what are transcendental equations and how to solve the questions using bisection method. If you haven't watched the previous video, please do watch it to understand how we can solve the questions using bisection method. So continuing with that, let's solve this equation. So the question is, find root of x e power x equal to 1 correct to 3 decimals using bisection method. So what is the equation? F of x is equal to x e power x minus 1, right? This equation we write it in the form of f of x. So f of x is equal to x e power x minus 1. So this one we are sending to the left hand side. Next, what is our first step? We have to find two numbers, and between which two numbers we can find out the root. Okay, we will find the numbers a and b, and we will be aware that between a and b we will have the root of the following equation. Okay, so how to find a and b? So f of a into f of b will be less than 0. Okay, that is how we find the root, that is how we find the interval a and b. So if at all some number, let's say f of x is equal to 0, x will be the root, correct? But we have to find two numbers a and b. So where f of a into f of b will be less than 0. So, and the root also lies between these two numbers. So let's try to find those. I'll just draw a table, and I'll be having f of x here, and I'll be having x here. So let's say my x value is minus 1. When we substitute minus 1 here, so what will be f of minus 1? So it's minus 1 into e power minus 1 minus 1. So which is minus e power minus 1 minus 1. The value of it would be minus 1.367. Next, what if x value is 0? So we substitute 0. F of 0 is 0 into e power 0 minus 1. So the value would be minus 1. Now, what if x value is 1? When x value is 1, we get 1.718. So I don't think we need to continue further, right? Because we got two values, a and b. So f of a and f of b is less than 0, right? If one is positive and other is negative, the multiplication of it would be negative and it will be less than 0. So f of 0 into f of 1 is less than 0, correct? F of 0 into f of 1 is less than 0, because f of 0 is minus 1 and f of 1 is 1.718. It will be less than 0. So we know that f of 0 into f of minus 1 is less than 0. So our interval is 0 and 1. Now let's go back to the question. So now we have got the interval. So I'll just draw another table. We'll be having I here. We will write down the interval a and b here. And what is xi in bisection method? It's nothing but a plus b by 2. So we know that in bisection method we keep shrinking the interval. So first we try to see where the root will be between a and b. So we divide a and b into two halves. We see if the root is in this half or this half. Once we get to know that, if we find that the root is in this half, then we will keep dividing this interval also. We'll keep shrinking the intervals until we find out the roots. So it was in detail in previous video. So now xi is a plus b by 2, and now we will also find out f of xi. Okay, this will be our table. Now in the first step, what is our a and b? A is 0, b is 1. The interval is 0, 1. So what will be xi? 0 plus 1 by 2, which is 0.5. So now what is f of 0.5? So f of 0.5 is, f of xi is xi e power xi minus 1, right? So f of 0.5 is 0.5 into e power 0.5 minus 1. So the value of it would be minus 0.176. I am using my calculator. So the value is minus 0.176, which is less than 0. Okay. So now this value 0 is giving us less than 0. F of 1 is giving us greater than 0, right? So 0 and 1. F of 0 is giving us less than 0. F of 1 is greater than 0. For root should be equal to 0, right? So root will be in this interval. Now the middle value is 0.5. What it is doing? It is also giving less than 0. So now we don't consider this interval. We take less than 0 and greater than 0. So as I mentioned in the previous video, always take the middle result. So 0.5 you should include in the next interval, and you have to check if we have to include the previous number or the next one. So this is giving us less than 0. So we will take one which is greater than 0. If this was giving us greater than 0, we would have taken the one which is giving less than 0. Okay. So this is giving us less than 0, right? So next interval would be 0.5, 1. I hope this is clear. So now what is our xi? 0.5 plus 1 divided by 2. Plus 1 divided by 2, which is equal to 0.75. Now f of 0.75 is nothing but 0.588, and this value is greater than 0. Now we got a value which is greater than 0. Okay, now we had 0.5, 1, and the middle number is 0.75. This was giving us less than 0, and this was giving us greater than 0. So, and 0.75 was also giving us greater than 0. So the root lies between greater than 0 and less than 0, right? So our next interval would be this. Okay. Previously the middle value was giving less than 0, so we took these two. So our next interval is 0.5, 0.75. That means our root is somewhere between these two numbers. Now what is xi? 0.5 plus 0.75 divided by 2, which is nothing but 0.625. Now what is f of 0.625? 0.625 is 0.168, which is again greater than 0. So now same way, now we have 0.5, it gives us less than 0. Next, what do we have? 0.75, it is giving us greater than 0, and the middle number 0.625, this is also giving us greater than 0. So we would take this interval because we need one which is less than 0 and the other one which is greater than 0, right? So now the fourth one is 0.5, 0.625. And what would be our xi? Actually, since this is I is 1, here we should actually write it as x1, x2, x3 and x4. So x4 is 0.5 plus 0.625 divided by 2, which gives us 0.563. I am rounding to 3 decimals as mentioned in the question. Now what is f of 0.563? This is minus 0.011, which is less than 0. Okay, so this was less than 0, this was greater than 0, and what is f of the middle value is f of 0.563 giving us less than 0. So what do we take? We take less than 0 and greater than 0, 1, right? So now our next interval would be 0.563 comma 0.625, right? Now what is our x5? 0.563 plus 0.625 divided by 2, it is 0.594. Now what will be f of 0.594? This is equal to 0.076. This is greater than 0 again. Okay, so this was giving us less than 0, this was giving us greater than 0, and this is also middle number is giving us greater than 0. So we know this middle number we will obviously include, but since this is greater than 0, we will include another number which is less than 0. So our next interval would be less than 0 is 0.563 comma 0.594. And what would be our x6? 0.563 plus 0.594 divided by 2. So x6 would be 0.579. Now what is f of 0.579? f of 0.579 is 0.033, which is again greater than 0. So this is less than 0, this is greater than 0, and the middle number is also greater than 0. So we would take the middle number and a less than 0 one, correct? Now seventh one would be 0.563 comma 0.579. Are you noticing? Initially we started with what? 0 and 1. Now our root is between 0.563 and 0.579. We have shrinked the interval very much. So x7 would be 0.563 plus 0.579 divided by 2. So it would be 0.571. Now what is f of 0.571? It's 0.011, again greater than 0. This is less than 0, this is greater than 0. So what we would take? Whatever the middle value we are finding out, and since this was greater than 0, we will include it, and we will take the less than 0 one from our previous interval. So 0.563 comma 0.571. I'm just repeating again. If this was less than 0, we would have taken greater than 0 number from our previous interval. Okay, so now our x8 would be 0.563 plus 0.571 divided by 2, which is again 0.567. Okay, now if we do f of 0.567, this is approximately now 0. Okay, so rounding to 3 decimals. So the root is 0.567, correcting to 3 decimals. I hope this is clear. In the next question, we will solve finding the root of x cube minus 4x plus 9 equal to 0 using bisection method. I think you can also try from your end, and then we can cross check all our answers. So this also is correcting to 3 decimals. Okay. Thank you. See you in the next video. Please subscribe if this is helpful. Hello everyone, welcome back. So in the previous videos we have seen how to solve the questions using bisection method. So now let's continue. The question is, find the root of x cube minus 4x plus 9 equal to 0 using bisection method, correcting to 3 decimals. So we know that the first step is we have to find two numbers a and b such that f of a into f of b will be less than 0. Okay, so we should keep substituting numbers in place of x, and we have to find any two numbers where f of a into f of b will be less than 0. So one of this should be negative and other one should be positive. Okay, so now let's see what is f of minus 3. So f of minus 3 is, this is just hit and trial of getting two numbers. I have already solved in my notebook. So f of minus 3 is minus 3 whole cube minus 4 into minus 3 plus 9. Okay, this gives us minus 6. Now let's see what is f of minus 2. F of minus 2 is minus 2 whole cube minus 4 into minus 2 plus 9. So this gives us 9, right? This is minus 8 and plus 8 gets cancelled and 9. So now do we see here, f of minus 3 is negative and f of minus 2 is positive. 9 is positive. So we got two numbers where one is negative and one is positive, right? F of a and f of b will be less than 0, right? F of a minus 3 into f of minus 2 will be less than 0. So that means what? Root lies between minus 3 and minus 2. So this tells us that root lies between minus 3 and minus 2. So now we have to keep shrinking the intervals. Okay, so we have minus 3, minus 2. We'll divide it into half. We will see where the root can be between. We'll check if it will be in this half or this half. After checking it, and then we will find the root in that particular half. For example, if we know that the root is in this half, then we will keep shrinking these intervals. Okay, so now let's start. I'll just draw a table. First one would be I, and then next column would be our interval a comma b, and then we have xi, which is a plus b by 2. Then we have f of xi. So in the first step, our interval is minus 3 and minus 2. So minus 3, minus 2. Minus 3 was giving us less than 0. Minus 2 was giving us greater than 0, right? F of minus 3 was less than 0 and f of minus 2 was greater than 0. Now we will see what is xi. Xi is a plus b by 2. So it's minus 3 minus 2 divided by 2. It's minus 2.5. Now what is f of minus 2.5? It is 3.375, which is greater than 0. Okay, so now if we see here, we had minus 3, we had minus 2. This was giving us less than 0. F of minus 3 was less than 0. F of minus 2 was greater than 0. So the middle number is minus 2.5. What it is doing? It is giving us greater than 0. Okay, So we know that root lies between f of a and f of b, and f of a into f of b should be less than 0. So this is giving us less than 0, this is giving us greater than 0. So we'll neglect this interval and we'll consider this interval. Okay, because we are again getting something which is giving us greater than 0. So all these intervals also would give us greater than 0 only. So another trick which I told in the previous video was, if you have something which is giving us greater than 0, then take something which is giving you less than 0 from the previous interval. Okay, here minus whatever middle value we are getting, we should for sure take. So the middle value is giving us greater than 0. So from the previous interval we will take something which is giving us less than 0. Okay, in the previous interval what is giving us less than 0? Minus 3. So we'll put minus 3 as it is, and the other number is minus 2.5. Now the root lies between minus 3 and minus 2.5. Now what is xi? Xi is minus 3 plus minus 2.5 divided by 2. Okay, it's minus 3 plus minus 2.5 divided by 2, which gives us minus 2.75. Now what is f of minus 2.75? It's minus 0.797. This is again less than 0. So if we got something less than 0, we'll include this. Even if we get greater than 0 also, we'll include this. But since we got less than 0, from the previous interval, we will take something which gave us greater than 0. Previous interval, this is giving us less than 0. This was giving us greater than 0. So we will take something which is giving us greater than 0, right? Because minus 2.75, this gives us less than 0. So we will take minus 2.5 along with it. So this is less than 0 and this is greater than 0. So the interval lies, our root lies between these two numbers. Now xi is minus 2.75 plus minus 2.5 divided by 2, which is minus 2.625. Now f of minus 2.625 is 1.412. So this is greater than 0. Now tell me what we have to include from these two. This value will for sure include. Okay, the middle value will for sure include in the next interval. But since this is giving us greater than 0, from the previous interval what we will take? Something which was giving us less than 0. So the next interval would be minus 2.75. This was giving us less than 0, and minus 2.625. This is giving us greater than 0. So the next root would be between these two numbers. Now what will be our xi? Minus 2.75 plus minus 2.625 divided by 2, which is minus 2.688. Okay, so now we'll do what is f of minus 2.688. F of minus 2.688 is 0.338, which is greater than 0. Okay, so this value again is greater than 0. So we will take less than 0.1 from our previous interval, which is minus 2.75, and we are going to include this minus 2.688. Now what will be our xi? Minus 2.75 plus minus 2.688 divided by 2, which is minus 2.718. And f of minus 2.718 is minus 0.225, which is again less than 0. So we got something less than 0. So this was less than 0. This was greater than 0. And the middle value is also giving us less than 0. So we will include the middle value. But since this is giving us less than 0, from previous interval what we will take? Which was greater than 0. So minus 2.718 comma minus 2.688. Now xi is minus 2.704. F of minus 2.704 is equal to 0.054, which is again greater than 0. So if this is greater than 0, what we will be taking from the previous interval? We will be taking something which was less than 0, right? So this is less than 0. Minus 2.718 comma minus 2.704. You are seeing how much we have stringed our interval. Previously it was between minus 2 and minus 3. Now we came to know that our root is between minus 2.718 and minus 2.704. So we have stringed it a lot, right? Now what is xi? Minus 2.718 plus minus 2.704 divided by 2, which is minus 2.711. Now f of minus 2.711 is equal to minus 0.090. Now this is less than 0. So this was less than 0, this was greater than 0, and the middle value we should for sure include in the next interval. This is less than 0. So since this is less than 0, we will take greater than 0 one from our previous interval. Okay. So minus 2.711 and greater than 0 from the previous interval is minus 2.704. Okay. Now our root should lie between these two. Now what is xi? Minus 2.711 plus minus 2.704 divided by 2, which is minus 2.708. F of minus 2.708 is equal to minus 0.026, which is less than 0. So again, so this was less than 0, this was greater than 0, and this is what it is giving us, less than 0, right? So we will take greater than 0 one from our previous interval. Okay. So minus 2.708 less than 0 and minus 2.704. What will be our xi? Minus 2.708 plus minus 2.704 divided by 2, which is minus 2.706. Now f of minus 2.706 is equal to 0.009, which is greater than 0. So this was less than 0, this was giving us greater than 0, and this is again giving us greater than 0. So this value will for sure include in our next interval. So along with this, what we will be taking? Something which is giving us less than 0, right? So 10th one, what it is giving, what is the value which was giving us less than 0? Minus 2.708 comma minus 2.706. So now our root should lie between these two. What is xi? Minus 2.708 plus minus 2.706 divided by 2, which is minus 2.707. F of minus 2.707 is minus 0.008. It is less than 0. So if it is less than 0, this was less than 0, this was greater than 0. Now whatever we got is less than 0. So what we will be taking in the next interval? So minus 2.707, and since this was less than 0, we will take something which is giving us greater than 0. So which is minus 2.706. Okay. Now xi is minus 2.707 plus minus 2.706 divided by 2. It's minus 2.707 again. We are seeing that the values are repeating. So that means we can say that this itself is our final answer, or root of x cube minus 4x plus 9 equal to 0 is minus 2.707. So we have corrected to 3 decimals. Okay, I hope this is clear. If this is clear, hello everyone, let's solve the next question. Find the root of cos x is equal to x e power x correct to 3 decimals using bisection method. So in the previous 3 videos we have seen how to solve questions using bisection method. I would request you to have a look on those 3 videos before we solve the questions. Okay, so coming back to the question, f of x is cos x minus x e power x, right? Cos x, we send this term to the left hand side. So cos x minus x e power x is f of x. So in bisection method, we have to find out two numbers a and b such that f of a into f of b will be less than 0. F of a times f of b will be less than 0. If at all you know a number, let's say x, when you substitute the x, if it is giving us 0, what does this mean? This means that x is a root, right? But we will find out two numbers a and b where this gives us less than 0, this gives us greater than 0. That means we are aware that the root lies between a and b. What we do next? We just divide the interval. Okay, we find the middle value a plus b by 2, and then we see if the root is between this half or this half. Let's say the root is between this half. Then we keep shrinking the interval further and find out the root. So that is how we do using bisection method. So now let's draw a table. Okay, so we'll be having x here and f of x here. So let's say x value is minus 1. What is f of minus 1? Cos minus 1 minus 1 e power minus 1. So it would be 1.367. Just one small note here that we should change the mode to radians in some of our calculators. By default it might be angle, so for the correct results we have to change it to radians while we are solving the questions. So let's substitute 0 now. So f of 0 is 1. Let's substitute 1 now. F of 1 is minus 1.71. Okay, so now we got two numbers, right? F of a, f of b. F of a into f of b is less than 0, right? F of 0 into f of 1 is less than 0. Correct? One is positive, other is negative, and multiplication of both of them is negatives, which is less than 0. So now we know that the root lies between 0 and 1. So now let's draw the table. So we'll be having I here. We will be having interval a comma b, then xi, which is a plus b by 2, and then we'll be having f of xi. Now first step, we know that the interval is 0 and 1. Okay, so this was giving us greater than 0 and this was giving us less than 0. And now what is xi? 0 plus 1 by 2, right? Xi is 0 plus 1 by 2, which is 0.5. Now what is f of 0.5? It's 0.1756, which is greater than 0. So in the previous questions, if you watch my previous videos, we have seen that in the next interval, this middle value we will for sure include. So since this middle value is giving us greater than 0, So we will take less than 0 from our previous interval. If this was giving us less than 0, we will take greater than 0 one from our previous interval. Okay. So this is giving us greater than 0, right? 0.5 is giving us greater than 0. So we will take something which was giving us less than 0 in the previous interval, which is 1. So next interval would be 0.5 comma 1. So now we have further shrinked the interval. Previously we knew that our root is between 0 and 1. Now we are shrinking. Now the root would be between 0.5 and 1. Okay. Now xi is 0.5 plus 1 divided by 2, which is 0.75. What is f of 0.75? It's minus 0.58. This is less than 0. So here if you notice, this is giving us greater than 0, this was giving us less than 0. And now the newer middle value is giving us again lesser than 0. So we'll include this, we'll include 0.75, and this was giving us less than 0, right? So in previous interval we'll take which is giving us greater than 0. So it's 0.5. Now our next root lies between 0.5 and 0.75. So this is 3, third step, right? So it will be x3. So here it should be x1, x2, x3. Now what is x3? 0.5 plus 0.75 by 2, it's 0.625. F of 0.625 is minus 0.16, which is again less than 0. Okay, so this is greater than 0, this is less than 0. Newer value is giving us less than 0. So 0.625 is giving us less than 0. So we will take which was giving us greater than 0 from previous interval, right? So 0.5 comma 0.625 will be our next interval. So x4 is 0.5 plus 0.625 divided by 2. So which is 0.5625. Now f of 0.5625 is minus 0.14. This is again less than 0. So if that is less than 0, we will take which is giving us greater than 0 from the previous interval, right? 0.5 comma 0.5625. Now what is x5? 0.5 plus 0.5625 divided by 2. So this will give us 0.53125. So f of 0.53125 is minus 0.04, which is less than 0 again. Okay, so here I did a small mistake, that is we have to actually round to 3 decimals. I have written the entire value. So I think it would be good if we round, we'll get the answer more quickly. But anyways, I am continuing. So this is less than 0, right? So this was giving us greater than 0, this was giving us less than 0. The middle value will definitely include 0.53125. Since this is less than 0, we'll take something which was giving us greater than 0 from the previous interval, 0.5 comma 0.53125. Okay, and now what is x6? When we divide these two, when we add 0.5 plus 0.53125 divided by 2, we are going to get 0.5155. So let's round it to 3 decimals from now. So it's nothing but 0.516, right? Now f of 0.516 is 0.0053, which is greater than 0 now. Okay, now 7th step. So this was greater than 0, this is less than 0. Now if we have something greater than 0, we'll definitely include this, But since this is giving greater than 0, we will take less than 0 value from our previous interval. So in the previous interval, this was giving us less than 0, right? So we'll include that and this. So 0.516 comma 0.531. I'm just taking 3 decimals. Now what is x7? So 0.516 plus 0.531 divided by 2. So this is 0.5235, but since we are rounding to 3 decimals, it's nothing but 0.524. Let's stick to that. So f of 0.524 gives us minus 0.01, which is less than 0. Now this was giving us greater than 0, this was giving us less than 0. Since this is giving us less than 0, now the middle value is giving us less than 0, we will take greater than 0 from the previous interval and this one. Okay, greater than 0 from the previous interval is 0.516 and this value is 0.524. So now our root lies between 0.516 and 0.524. So 0.516 plus 0.524 divided by 2 is 0.520. Okay, now f of 0.520 is minus 0.006, which is less than 0. So this was greater than 0, this is less than 0, and this is again middle value is also giving us less than 0. So what we will do, we will take this value for sure, 0.520, and we'll include whatever was greater, giving us greater than 0 in the previous interval, right? So 0.516. So 0.516 comma 0.520. Now x9 is 0.516 plus 0.520 divided by 2, which is 0.518. Now f of 0.518 is minus 0.0007, which is less than 0. But one thing to notice here is for 3 decimals it's 0 only, right? 0.000 is nothing but 0. If some value f of x is giving us 0, that means this x is the root. So this is giving us 0, rounding to 3 decimals. So we can say that 0.518 is the root of cos x minus x e power x. So either this value approximately becoming 0 will give us the root, or if we notice that x8, x9, x10, if the values are same, then also we can say that this is the root. Okay, either ways. So in the previous question, if we notice, here the values were minus 2.707, minus 2.707. So the values are, almost they're same. So we can say this is the root. Or if f of that value is giving us 0, then also we can say this is the root in bisection method. So 0.518 is the root of cos x minus x e power x. So the previous question that I have shown is in the previous video. Okay, thank you. See you in the next video. Please subscribe and share it with your friends if you find this helpful. Thank you.